had talked about before, I am part of the hypersonics lab on campus. And today I'll be talking more specifically about particle image velocimetry and seeding force in that PIV. So as Angie has said before, there's a lot of non-intrusive methods that are needed to measure velocity within our systems in order to prevent or to better model velocity effects. So one thing is an example of high hypersonic flows is reentry vehicles when they are deorbiting are reentering at about Mach 25 or 25 times the speed of sound. So it's a very extreme environment and very difficult to actually model and measure values. So PIV is one of those methods. Itself, PIV is measuring and is taking images such as this top image here of tiny little particles, which in our lab we are using titanium dioxide, which is a very small nanoparticle that's actually used in toothpaste for whitening, for bleaching and whitening. But for our purposes, it actually illuminates under a laser sheet, and we can actually take a photo at 2 separate times using a high-speed cameras that once again Angie described, and take this photo here. So you actually don't just see the particles once, but you actually see particles at 2 different spots. And we can use that difference in space and time and do cross correlations to create this graph here and create a velocity field. So we can determine the velocities at different places within our tunnel. For instance, this photo, this system here is specifically at the floor of the tunnel. So the one problem with our current setup is that the seeding mechanism was not the greatest and we needed to improve it. So the hope would be to create some sort of method or use various methods to try to figure out a way to properly seed and get a good density and spread so we can properly image and then eventually make a velocity field. So this example here is a cyclone seeder, which is a device that Glass and Kennedy had developed and represented in their paper. And it involves using any gas, specifically for our case would be air, and putting it into a tangential spiral along a cylinder. That cylinder, then once it hits the powder, once again for our system, titanium dioxide, causes the heaviest particles to go onto the outside and spins the smallest and lightest particles into a cyclone all the way through the top of the system. This tiox or powder ends up becoming an aerosol into our system, specifically to do for our wind tunnel and seeding. So I had taken a couple of designs here and had developed this final product here on the left. Thank you.